Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out my previous videos to follow along. In today's problem, we will work on valid anagram. So the problem states that we're given two strings yes and t, and our task is simple. We will check whether one string is just a rearrangement of the other. No extra characters, no missing characters, just shuffled letters. So let's start with a brute force idea and then we will move to the optimal approach. So the idea is if the lengths are different, then we can simply say it is not an anagram. And we would sort both the given strings and we would compare character by character. If they are same, then we would return true, otherwise we would return false. So let's check if the length is same. If yes length is not equals to t length, then we would return false. Now let's convert this into a char array. Yes array would be yes dot to char array, and we would convert t to the array, which is t dot to char array. Now we will sort both of them. Arrays dot sort yes array and arrays dot sort t array. Now we will check if they are equal. Return arrays dot equals yes array and t array. If it is, then it will return true, otherwise it will return false. Let's run the code. Okay, it is working. So the time complexity would be n log n and the space complexity would be O of n because we are using extra space in the form of arrays. So the sorting works here, but we are doing some extra work. We can do better using frequency counting. So for the optimal approach, uh, we can follow the frequency count pattern where see, two strings are anagrams if every character appears same number of times in both the strings. So just like how we checked for the brute force approach, if the lengths are different, we would return false. Otherwise, we would create a frequency array of size 26 and we would increment the characters in S and we would decrement the characters in T. At the end, if any value is not 0, then it is not an anagram. So initially we will check if the lengths are not or are equal or not. Then we will initialize one frequency array of size 26 and for each character C in yes dot to char array we would increment that character. Let's make it minus a to get the index and we would increment it. And similarly in T array, and for every character C in T dot to char array, let's decrement it. C minus a minus minus. Now we will check if every element is 0. So for let's say count in the frequency, if count is not equals to 0, then we would return false. Otherwise at the end we will return true. Let's run the code. Okay, let's submit it. Okay, it is accepted. So let's try run a small example. For example, if you consider this example 1, the frequency array after updating, after this for loop would be at A the count would be 3, and at N the count would be 1, at G the count would be 1, R the count would be 1, and M the count would be 1. Okay, now after this for loop, since we are decrementing for every character, the frequency array will contain all zeros. See, because this N would cancel out this N, this AG, AG, ARAM, ARAM. So it would cancel out and the frequency count would be 0, and hence this is a valid anagram. So the common mistakes which people do in this problem is they forget to check the string lengths, and using sorting without understanding the time complexity, like how we did in brute force approach, and not handling the character frequencies correctly. So yeah, so valid anagram is a classic hashing or frequency count problem, and once you think in terms of counts instead of order, the solution becomes clean and optimal. So yeah, that's it for today's problem, and I'll see you in the next one.